This is topic 17, average and instantaneous velocity. So the definition of average velocity, as you hopefully remember from physics, is the change in position over the change in time. All right, just so you become familiar with the notation, S of t is a function that describes the position. All right, so S of t describes the position of an object at time t. So the average velocity is described as the final, this is the final position, right, minus the initial position, and that's what they mean by the change in position. So initial position over the difference in time. All right. So the average velocity function can also be described as a slope between 2 points. All right. So this is actually a slope between 2 points, and this is depicted on this graph, on this line right here. So we can say that this would be, for example, A, this would be B. So this secant line, all right, the secant line that touches 2 points, all right, this would be describing, or this would be depicting the average velocity. So this is the secant line, so this would be the average velocity. All right. Now, the more interesting part would be the instantaneous velocity, right? The instantaneous velocity is the slope of the curve at a point, all right? And when it says a point, they mean a single point. Right, so is basically what it is, if you look at this graph, this is the slope of the tangent line at a given single point, all right? So this line right here, which is the tangent line, describes the instantaneous velocity right, so this describes the instantaneous velocity of the position function. It's also called the tangent line here. It's also called the derivative at that point. So every time I ask you from now on, what is the derivative, for example, at x or t is equal to 1 in this case? Well, your answer would be the slope of this line. So the slope of this line actually gives me the derivative at that point. Okay. The other thing I got to point out here is notice that even though this is not labeled, this would be S of t, and this would be t, all right? So on the bottom you have time, and on the side you have position. So this curve right here actually represents the position at any point in time between 1 and 3. All right, so again, if I ask you, well, where's this car or this person at 1.5? Well, this would tell you, if you knew the height, that would tell you the position of that person, all right? Now the difference is that the slope at every point here, the slope at every single point on here represents the derivative, or the instantaneous velocity in this case, since we're talking about position. All right, now let's go to the back. If you have more questions about this, make sure and ask. Let's go to the back here, and we're going to do something here that hopefully would clarify a few things. All right, they're asking us to draw the following and then put them in order from the least to the greatest. All right, so what I'm going to do here is I'm going to let the blue lines be the positive slopes, and the pink lines would be the negative slopes. Right, because at some point I'm going to draw a lot of lines, and I want to make sure you understand which one's which. Like, what am I talking about? Right? So the average velocity, they're asking us to draw the average velocity of AB. Remember, the average velocity is depicted when you draw a line through the 2 points and then find the slope of that. All right, so the slope between those 2 points, that gives me the average velocity. All right, now I'm going to draw this and then label those later. All right, the average velocity of BC. All right, BC. The average velocity, again, is the slope between those 2 points. And sorry that if I repeat myself a lot of times, I just want to make sure you understand this, all right? Now, the average velocity of AC would be this line right here. Notice there would be a positive line, positive slope, that is. All right, so that's BC. And if you keep reading right below, it says the instantaneous velocity at A, which is the slope of the graph at A. All right, so let's make sure we understand. We got to draw a line that goes right through A. It only touches this function at one point. All right, on your homework, all right, I've seen this mistake happen quite a bit. If I ask you for example, instantaneous velocity at B, notice how I'm drawing B also. I'm only touching one point on this curve. All right, and then finally instantaneous velocity at C, which would be this. And just to make something clear, if I ask you for the tangent line on any curve, that tangent line, pretend like you have a stiff line or a pen. So as I go up here, that would be the derivative at every single point. It will look like that. Notice that I have no point am I crossing through the function twice, or am I doing something crazy like put the line like this or like that for the tangent line. All right. So again, if I were to ask you to draw every single tangent line for every point on here, it would look something like this, where you would have the tangent line touching only one point on this function as you go from the left side to the right side. So that's the way that would work, okay? So let's make sure we understand that. So for your homework, do that. All right, now that we have all that, all right, we're going to put them in order from least to greatest. So if you look at it, right, the slope that has the least or the most negative slope would be C. C would be the biggest negative number, and therefore that would be the least. So in this case, that would be the instantaneous velocity at C. All right, so this C is going to be 1. Right after that, the one with the most negative slope besides C would be BC. All right, so BC has the second most negative slope, and therefore that's going to be, excuse me about that.
Jason Sprague, if you're still in the building, please come to the front office. Jason Sprague.
All right, Jason Sprague, you're going to be in immortality in this video. Hope they find you, buddy. All right, so we have BC, which is, so this is going to be 2, right? As we continue, now notice that that's it for the negative slopes. I only have 2 lines for negative slopes, all right? So the strange thing about this note, so you're going to have at least one problem like that in your homework, is that you have, it says the number 0, all right? So notice that because I'm going from negative slopes to positive slopes, the next logical number that has to be here from least to greatest has to be 0. All right, as we move on, all right, that would be 3. Let's look at which one would be next. So the next one would be from least to greatest. Remember, I'm going to look at this one because this one seems to have the least positive slope. So I'm going to go to AC as my next option. All right, so this would be 4. All right, the next one, notice that B, for example, B has the least slope out of the ones that I have left. Okay, so that would be number 5. And let's go ahead and get something out of the way. Out of all the things that we have this slope right here, A. All right, the slope, instantaneous velocity at A. And we also have the average velocity between A and B. Notice that this line right here, I'm going to put my pen on it. That line right there is steeper than this line. So therefore the one with the greatest slope, if you will, would be A, which is here. All right, now the problem then becomes the average velocity of AB, right? If I were actually to get a slope here, if I were trying to get a slope here, I would say that the slope would be, I don't know, 1 over... be 1 over half, so I don't know, let's say that's 1 over a half, for example. Oh wait, this is AB. I'm looking at AB, I'm sorry. So that'd be 1 over, I don't know, it's less than 1, so I'm sorry. This would be something less than 1, let's call it 0.8, for example, up 0.8 and over 1. All right, for the sake of arguments here. So I have 0.8, and then I just have to figure out if 0.8 is greater than 1, and it's not. So the next one up has to be, let's see, 7, 6, and 7. That's what I'm missing. So this would be 6, and that would be 7. All right, so again, that's the part that's kind of confusing because it's kind of hard for you to approximate what the slope is on AB, for example. You can only approximate, so don't think about it too hard if you're getting stuck in some of this stuff, okay? If you're getting stuck in some of this stuff, then you're thinking probably way too hard about it, right? There is going to be some approximating that happens here, and therefore your answers might be different than what I have, all right? So let's do a couple of the homework, make sure we understand this, all right? On this one, on the homework, they're asking us which one had positive slopes, and on this one, we're only looking at tangents, all right? So tangent lines, which means you're only going to hit that point once, all right? So for example, let me just draw something real quick that will look like that. That would probably look like this. That would probably look like that, like this, like that, and like that. All right, so notice that the only ones that have a positive slope would be A and D. Okay, now in the next couple, which ones have the negative slope, right? So if you haven't done this, if you need to pause it, pause it. I don't want to just tell you all the answers, right? So notice that the only ones that have a negative slope would be C and F. All right, so C and F. The next question says, which one has the greatest slope? All right, the greatest slope means the steepest slope, the steepest positive slope, and in this case that would be A. And the least slope would be F, because you have this slope right here that is very, very negative. All right, so we have a large negative number making it the least slope. All right, as we move on, if we match the points labeled on the curve below with the given slopes, again, we're only doing tangent lines at this point. All right, so E would probably look like it would be 0. All right, after that, then you have a little bit of work to do. I would say that the slope for D would look like that. Remember what I talked about, right? You have a stiff line, basically, that you would follow all the way like that if you're doing tangent lines. Okay? So, for example, this one, that's what you would have here on A. A and B, I think, are the hardest one for me to do because they're so almost the same, but not quite. All right, so on the next part, we can hopefully at least agree that the biggest positive slope would be D, which notice that that's the biggest one between 1, 1/2, and 2. I'm going to pick 2 as being the greatest positive slope. Now, the choices are between 1 and 1/2. All right, now, it's really hard to tell on this one, but I'm going to say that 1 would be this one, and B would be that one. Okay. Normally, when you start here, if this is a concave down function, if you have a function that's concave down at this point, normally A is going to be steeper than B. Okay, so hopefully you understand that. All right, I'm going to stop there. If you got any questions, make sure and ask me. Hopefully you're watching this if you're absent. All right, so if you're absent, I hope you watch this. This is the basis of what we're going to do for the next few weeks. So make sure you really understand this.